Hello, welcome to the virtual AWS meetup group, formerly known as AWS Denver. Hope everyone's doing okay and feeling well and healthy. Thanks for tuning in. Today, we are going to dive into the first of a two-part series on AWS data pipelines. During that, we will cover various components of Kinesis to do data streaming things. We will also cover creating a data lake with S3 and Athena. And I think further down the road, more so in part 2 of the series, we're going to start looking at how to get into data warehousing with Redshift and connect that into S3 with Redshift Spectrum. We'll also look at creating an application, a shared application data store using Elasticsearch, but again, that is down the road during part 2. So let's go ahead and get into it. So just to introduce myself, my name is Kevin Tin. I'm a cloud application architect and a practice lead at Worldwide Technology, based out of St. Louis, but offices all over the globe. Over a decade of industry and experience, done a lot of development in the Microsoft land, namely in the forms of C#, VB.NET. Inside of the JVM in Scala, and then various front-end frameworks, node development in JavaScript, of course. Really gotten into data streaming architectures probably in the last like 4-ish years, using some platforms such as, and technologies such as Kafka, Kinesis, and Event Hubs, as well as getting into application architecture within AWS and Azure as well, also in on-prem. Fun fact, incessant traveler and newfound skiing addiction. And I lived in St. Louis for a little while, grew up in Tennessee, and now I am in Denver. And so just to kind of tell you what I'm going to tell you, I'm going to do a brief overview of data pipelines and event streaming as we got a late start. We are already behind schedule, but yeah, it's the fun of it. So 10 minutes roughly about overview of data streaming architecture, why we want to move away from batch to event streaming. Then look at the kind of the POC/demo overview and talk about what it is that we're going to look at today and the components. And then we'll get into the actual components of Kinesis of the demo, including Kinesis Streams, Firehose delivery stream, analytics applications, S3 and Athena. Then we'll take a look at some of the code that I've used to create the solution. The majority of the code is actually in the coded infrastructure. That is kind of the beauty of these serverless offerings, is there's very little to stand up, there is very little to actually code, and they integrate fairly seamlessly. So with that being the case, let's go ahead and jump into the repo. So I realize that this is just a presentation, a stream, so you can't click this, but if you go back to the meetup, you can find links to both the repo and also this slide deck as well. And as you travel to the meetup page, if you're not already a member, please go ahead and join. And so let's jump into why are we getting into streaming services, data pipelines, what's really the goal? So the goal is to move from a batch architecture to an event-driven architecture. And so for years, batch architectures in terms of the movement of data have pretty much dominated the industry. And it got to the point where there's just too much data really to scale out these solutions. And so the dependency between applications continued to grow to the point that understanding dependencies, if you wanted to migrate systems, for example, just really became so much of a spider web that managing the systems, and I think more to the point of this discussion, the data from the systems is really what we're trying to do. So we're trying to make a more scalable data architecture. And so that's what we're going to try to get into. So fairly simple depiction of two applications. They each have their own API, their own database, and you have a data warehouse. Pretty standard stuff. This looks fairly manageable. Sometimes applications have dependencies from other applications in an older traditional system where a one-day batch was not quick enough, like we needed quicker updates from the other system. The APIs from application 1 may actually talk to the database from application 2, which is a bit of an anti-pattern, especially when you start moving into microservice architectures. And so, like I said, with 2 applications, this looks fairly reasonable. What happens if you double the number of applications? And so as you double the number of applications, you really start to see the mesh of the communication really become unscalable. It just becomes ridiculous. And so with that being the case, we want to jump into some solutions to go ahead and figure out how to really kind of decouple the applications and make the movement of the data between the applications something that's a little bit more manageable, easier to understand, and also really quantified in case we want to migrate apps, sunset apps, etc. So moving into some modern services. With this paradigm, we have an application which has its own database and API layer wrapped up. It's a kind of an atomic unit, if you will. I realize that's not the exact perfect usage of the word atomic, but I think the real takeaway here is the application is the only entity interacting with its database, and it can do it through an HTTP API, it can do it through SQS, it can do it through whatever. With that being the case, no other application can touch that database, and anything coming out of that database that needs to be sent to a data warehouse or another application really just has to go through a data platform. And so at that point, the question might become, well, that seems fairly simple. At this point, you really just replace the batch process. Like, how is it better? And so, using technologies such as change data capture, message queuing, etc. At the point in which data is updated in the database for the application, those changes are then emitted out into the data platform. And at that point, the data platform, it doesn't necessarily have to know what applications need the data that's coming out of application 1. It just needs to make it available in case an application does. And so at that point, you have a data warehouse feed that is sitting there and probably listening to all applications, doing some transformation and then updating into the data warehouse. And then you have application 2 that's also sitting there waiting for messages that may be emitted from application 1, and vice versa. And so at this point, you can get near real-time updates between the applications and updates going back to the data warehouse. And so contrast that with this mess of a communication mesh that shows up when you scale out to simply 4 applications that are dependent upon each other. This really starts to scale out really nicely and becomes, I think, something that's just way more manageable. And so with all that being said, I think we've kind of set the backdrop for why it is that we want to get into kind of creating a modern data pipeline, and that's to enable an event-driven architecture, and that allows us to decouple systems and also react to data in near real time, which in the current computing industry can be the difference between getting a sale or someone using a competitor's service. So this has become more and more critical as users start to demand better and better experiences. So it's all for the user. We love them. So to just kind of give you a rundown of what it is that we are going to kind of look at building out today, let's start with the problem statement. And so pretty simple simulation of IoT data. So we have some sensors that are installed in manufacturing sites. They're picking up pressure readings and they're picking up temperature readings. And so these are being sent back into AWS, into a Kinesis data stream. And so at that point, some people care about pressure data, some people care about temperature data. So at that point, we split the data based on the sensor type. They're all coming into a single topic which has a field sensor type on it. For the pressure data, we are going to enrich that with the altitude above sea level, whereas that can affect pressure. And then for the temperature data, we're going to go ahead and enrich that with weather ambient data that will allow us to see, if this site is running hot, is it because it's hot outside or is it because the process itself is inherently broken? So those are the 2 types of data that we are ingesting on a Kinesis stream. Then we're going to use Firehose to take that raw data and just go ahead and put it out into an S3 bucket. Very common practice in data warehousing is to store the raw data and then transform it and store it again in the enriched form. That way, if you have to ever go back and add additional enrichment to the raw data, or for example, you got some bad data and then you enriched your raw data with bad data, you're going to want to go back and kind of redo that process. So the storage of raw data, very common, and it's honestly pretty powerful. So something we see commonly. So data comes in off the stream. And so let's go ahead and look at an image of this. So sensor producers send data into a data stream. From there, Kinesis Firehose delivery stream dumps everything out into a raw data bucket for reprocessing, data science activities, exploratory queries, etc. So from there, two analytical applications, Kinesis Analytics applications, pick up the data off the stream. One, the pressure application is picking up data with a sensor type of pressure intuitively. The second, the temperature application is picking up data with type of temperature in the sensor type. So with that being said, each of these two analytical applications uses an S3 source to enrich the data. Again, with temperature, we're going to go ahead and throw the ambient temperature of the site ID onto the message. With pressure, we're going to go ahead and throw the altitude of the site onto the message. Pretty straightforward, pretty small example, but I wanted to start with something kind of bite-sized and it's easy conceptualized, very few columns, etc. This grows pretty large pretty quickly, so let's start with kind of a small subject matter and go from there. So with that being said, the enriched data coming out of the analytics applications are then sent into a delivery stream, a Firehose delivery stream. And those are then just dumped directly into enriched data buckets. And so at that point, we've kind of accomplished the standard raw to enriched workflow that we see in data warehousing and data lakes very, very commonly. And so let's take this one step further. So now we've enriched the data. Well, what do we do with it? Well, that's cool. So we probably have some data scientists that would like to go and query it and, given a particular anomaly in either temperature or pressure, go and, take a look at, say, I don't know, the altitude of the site and see if the pressure kind of variance makes sense, or the ambient temperature of the site and see if, the site running cold or hot could be based on the environment. And so to advance further, I think this is the entire architecture. I think a lot of, more IaaS type of centric-minded people may have wondered, this is very high level, where are the VPCs, the subnets, the CIDR blocks, where are my security groups, etc. And so with that being the case, wanted to point out that this is all serverless. Like at no point do you have to stand up any kind of software-defined networking, any kind of VMs. You don't have to go and define security groups. There is security. We'll get into that later. But you're really not dealing with the standard software-defined networking that, really, is at the advent of cloud platforms, as well as virtual machines, etc. So you're kind of simplifying the picture, and you're putting a lot of the back-end infrastructure work on the platform itself, which I think that's pretty much always the goal. Simplify. And so as we start to get into this, I'm going to go ahead and start to spin up the infrastructure. So a word on the infrastructure. I went ahead and used PuluMe to create the IAC. If you're not familiar with PuluMe, I have a prior meetup that I did kind of comparing and contrasting Terraform and PuluMe. Not that I think one's better than the other. They're both great products. They're just two different offerings. And so I've gotten into that pretty heavily, kind of geeked out on it. And so I want to do kind of a bake-off between the two. And then, for this specific example, I wanted to use PuluMe because shout out to PuluMe. They just released a 2.0, and that includes full fidelity between all of the languages. Prior, you could do some things, with the Python implementation, and maybe you couldn't do those with the C# implementation, which was in preview. So now C# is fully supported, has all of the support that what were prior fully implemented, like the JavaScript, TypeScript, and also the Python providers. Now everything's on equal footing, and there's a lot more languages that you can use. So like I said, big fan of Terraform. I work at Worldwide Technology. We are a partner with Terraform with HashiCorp. We were Rookie of the Year, in fact. So, don't take anything the wrong way. We are definitely big fans. I just kind of wanted to see what the C# language support for PuluMe was like. So without further ado, let's go ahead and jump into it. So at this point, I'm going to go ahead and get into just a very brief overview of the project. And so using Visual Studio Code here, you do a PuluMe new, it'll give you a C# kind of boilerplate. Jump into it, and it runs a stack, and it goes ahead and creates things. We'll get into this further, but the long and short of it is, within this data science stack that I am standing up, we've got some S3 buckets. We've got a Kinesis Stream. We've got some Firehose delivery streams, some analytics apps, and the Athena database. There's a couple manual steps that I couldn't quite get coded, so we'll also cover those as well, namely creating Athena tables within the database that is instantiated, and also starting the Stream Analytics applications. So we'll dive into the portal to do those things. But first, let's go ahead and spin up the stack. So with all that being said, I am in the infrastructure as code folder within my project, within my repo. So if you're following along at home, if you go to, let's see, I've lost my browser. There we go. LinkedIn page. Feel free to connect. I probably need a few more connections, to be honest. So let's go ahead and just take a quick look at the repo in case you are following along there. So github.com/kevasync. That is me. So we are in the data services. So inside of the infrastructure as code folder within the root of the repo, we've got all of these C# files, and this is where the coded infrastructure lives. So just to give you kind of a rundown if you were following at home, but anywho. So like I said, we'll get back into this, but let's go ahead and create the thing. So with PuluMe, it's as simple as after you've created a new workspace, go ahead and PuluMe up. There's some authentication that you need to do to log into both PuluMe and AWS. That's all covered, in full detail in the aforementioned Terraform and PuluMe meetup that's out there on GitHub as well, underneath github.com/kevasync. It's the repo with Terraform in the name. So, all right, so let's go ahead and stand up said infrastructure. So this takes a little bit of time. While that's going down, let's go ahead and talk about at a little bit more detailed level. I've thrown around some terminologies, some product names, and maybe you know of them, maybe you don't. So we'll just kind of run down the full stack here. Kinesis Data Streams, massively scalable, highly durable ingestion, many-to-many publications, pub sub, that sort of paradigm, supports that quite well, scales out massively, as AWS's own product blurb points out. Fully managed, like I said, no VMs, no VNets, no VPCs. Sorry, we're in AWS. And so each stream consists of shards, which you can scale up to allow for parallelism. If you get into a production scenario where you have thousands of messages per second flowing in, maybe even more, you will want to most certainly increase the number of shards. For demonstrations, single shard works out pretty well. Low volume, single shard, reduce the cost, go for it. So messages are also produced with a partition key, so you can do some kind of time-ordered processing there, getting the same, so you have a pressure and sensor reading for a particular site ID. You can use this partition key, being the site ID, to get the pressure and temperature readings from a particular site all on the same partition. If that's of value for you, I think that's maybe a little bit more advanced data streaming use case that, hit me up on LinkedIn or chat with me on the meetup event page, and we can talk through that if that's something that you are seeing, but I don't want to dive too far down that. So, and just a word to the wise, when dealing with stream processing, always make your consumers idempotent. So what does that mean? So if you get a message and then you put it in a database and then you get the same message the second time, the exact same message, instead of creating a second message with the same content, overwrite the old message. So it's kind of, if you're thinking of it from the HTTP verb perspective, make your consumers be able to support a put and not a post. And so just a tip. We've seen that with some of our customers where they didn't anticipate getting the same message multiple times because it's something that happens in stream processing pretty commonly, and they blew up, and it was not great. So definitely follow idempotent processing principles when streaming. So next, the Firehose delivery stream. And so the Firehose delivery stream is a fully managed service for streaming data to destinations. So you can either dump data, commonly referred to as a data sink in the data platform world, to sources without writing any code. So inside of AWS, Kinesis Firehose delivery streams can deliver to currently S3, Redshift, Elasticsearch, and Splunk. And so we are obviously going the S3 route today. I think in part 2, we'll probably get into both Redshift and Elasticsearch. Love you too, Splunk, but we're not going to have an example of that. So there are some light mappings that you can do as well in case you want to do some ETL in your delivery stream transforms. And so pretty good options there, but the long and short of it is I have data on a stream and I want to get it off the stream and into some sort of persistent store. I don't want to write code. What in the world do I use? Firehose delivery stream. Works a charm. So the Kinesis Analytics applications. This is by far the most complicated component within today's demonstration. And so with Kinesis, you can join the data from multiple streams or from a stream in a reference data set coming from a file in S3, which is what we're going to do today. Pretty good, pretty hot. And go ahead and use like a standard SQL-like syntax. It's not ANSI-SQL compliant, but it is a SQL-like syntax that most people that have done any kind of work in relational databases can understand and learn very quickly. And so these allow for the real-time joining of data, enrichment of data, and then sending it downstream. And so we use this in today's demo to go ahead and combine the temperature readings with the ambient temperature of the environment. And we also use one of these to enrich the pressure readings with the altitude of the site, in case those may affect what readings we're getting. And so with that being said, you can also use Apache Flink as well. I think for me, it's definitely easier just to use the SQL syntax. It's something that I just picked up quickly. And also, if you've worked with Kafka, a Confluent Kafka platform, and you've used KSQL or Kafka SQL, same concept. So I've seen this in a variety of streaming platforms, and for me, it's easier just to use the SQL syntax. There's also less development work there. Okay, so moving on, we have the S3 and Athena data lake that we're going to create. So S3, commonly known, heavily used, simple storage service, provides object storage. I don't know if it needs much more of an introduction. Athena, however, may be more of a niche service. And so Athena is a service that you can create a database in and point it to a S3 bucket, and then you can go and query the data in your S3 bucket in a SQL-like syntax. The SQL-like syntax that show up all over the place. It's definitely pretty easy to work with. So with all that being said, we go ahead, configure Athena to look at a table, to a S3 bucket, create a database off of that. We can create various queries, etc., to define a table. And then from there, we can go ahead and dive into data, do exploratory data queries, etc. So really, it's a pretty good tool for exploratory data science work. So supports a variety of files. I think there's 2 more out there that I didn't even mention. Yeah, pretty flexible, pretty interesting. Okay, so now that we've gone through the rundown, let's go ahead and take a look at the PuluMe deployment. So we have deployed a bunch of stuff, unordered of course, thank you. So some buckets, some roles, some logs, and of course the delivery streams, the stream itself, the Athena database, etc. So I've specified some outputs, as these are pretty useful for our for our demonstration. The first of which is this stream name. And so this is an identifier for the stream that clients use to write to it. So given this is an output from PuluMe, I've got an application, a Python application that simulates the production of sensor data. It pulls stream name from the environment, so it's easy enough just to go ahead and export these PuluMe stack outputs into environment variables. If you want to go ahead and just double check that it worked, do that. There you go. We got the 0D2, and let's see, stream name ends 0D2 CB0. Yep, so we got the right value. All's well that ends well. So with that being said, I'm going to go ahead and grab the reference data bucket. The reason I'm going to do this is because I want to go ahead and upload the reference data that's going to be used by the Kinesis Stream application. I will say, of all the manual steps, uploading an S3 file, a bucket object, is something that you can certainly do. I didn't do that because we were going to go to the portal anyway, so I figured, hey, let's go look at the infrastructure. So let's see here. Get into our sandbox. Coolio. All right, so get into S3. Got quite a few buckets. This is a shared sandbox account. We've got our reference data, and this matches the output from the PuluMe stack. Sanity is intact. So here, let's go ahead and add our reference files. I've done this before, so it remembers my location. While we're doing that, let's go ahead and jump in and take a look at these. So let's see here. We've just got some CSV files, so sites 1 through 10. We have the outside weather, temperature, ambient temperature, if you will. Again, sites 1 through 10, we have the altitude, number 1 being Denver's altitude naturally. So with that being the case, jump back in here. Our uploads have completed. So in the grand scheme of things, next we need to go out and start the Kinesis Analytics applications. And honestly, this is a pretty good opportunity to just take a look at Kinesis Analytics applications and Kinesis in general. So let's go ahead and just take a tour of the various things that were created. As promised, one stream, our IoT sensor readings incoming, so we have the pressure and the temperature readings are going to be coming in on the stream. So pretty cool. Delivery streams. If you think about, let's go back to the diagram. Whoops. So if you think about the diagram here, we are outputting to 3 different S3 locations. So we need a delivery stream for our raw data, we need a delivery stream for our enriched data on the temperature side, and we need a delivery stream for our pressure data that's been enriched. So it's probably worth noting that these 2 streams could just put into a single bucket. I thought it was maybe a little bit more intuitive to use 2 different buckets. And Athena can also query from 2 different folders within a single bucket, so we very easily could have pulled this off with a single enriched data bucket. But I thought that was maybe a touch more confusing, and with S3 you're getting charged for the storage you use, so why not? So with that being the case, back in here are our 3 different delivery streams. So we have the pressure producer, so this is the delivery stream that's going to be the enriched pressure data, the temperature producer, which is going to be your enriched temperature data, and then also just the sensor producer. Maybe that could have been named a little bit better, but that's going to be your raw data. And you can see that, let's just dive into the raw data. You get into here, specify a source, that's that stream, specify a destination, and it's just going to output into the raw data bucket that we set up. So with that being the case, I think it's probably worth taking a look at the other 2 delivery streams real quick, whereas we have a source on those, but we do not, well, we do have a destination. Okay, so that got hooked up in the creation of the analytics application. So very cool. So anyway, so let's go ahead and jump into the analytics applications. And this is where the real kind of meat of this is occurring today. So that being the case, we have a pressure analytics data. Looks pretty confusing, so let's just dive into it and look at all of the various components of an analytics application. So we have an input source. No surprise here, it's that same input stream. So if you're seeing a pattern here, we have one input stream and we have three processes that are fanning off of that input stream. If we go back to the why do we care about event streaming, that lines up pretty nicely with this. And so with that being the case, we really started to reduce the amount of processing. So we really start to, for example, I think to really tie it back to this diagram, application 1 has a stream of updates. Applications 2, 3, and 4 through application N, if you want to scale this out massively, go ahead and just pick up data off of that stream. And so this one-to-many processing becomes really important. And in the case of IoT data, the many-to-many becomes very important because you would have multiple sensors producing into this topic, and then obviously we've got 3 different consumers coming off of, not topic, but a stream. I'm mixing up my terminology between platforms. So anyway, diving back into the platform itself, there's also a destination, and so that's going to be that Firehose delivery stream, pretty straightforward. And the real kind of, I don't know, you could say magic occurs in the analytics. So this is what I was talking about. I did not find a way to do this in the coded infrastructure. I may have ran out of time, don't hold it against me, to start the application. So this one has to be started, the pressure analytics. So with that being the case, the other one also probably has to be started. So let's go ahead and do that. So we can see the state over here, changed to starting. Very cool. Let's go start the temperature. So we will come back here. And so as these are starting, let's go ahead and start to set up the other manual component of this, and that is the Athena table. So going back into the services, we'll take a look at Athena. And so let's just go ahead and set up a table real quick. So we had a database that was created from the coded infrastructure, but to query, we need a table. So we're just going to go ahead and create that from the S3 bucket. Select the original, select the existing database. Let's just go ahead and call this one pressure. At this point, we need to go and get the pressure bucket name, and let's go ahead and do that. So this will be S3:/ bucket name / this is a little tribal knowledge of the Firehose. The Firehose inserts records into the bucket based on the date. So we're just going to constrain this to 2020. So if there was data from other years, we'd only be looking at 2020. But anyway, so this is important. I'm doing this to show you that say we had one bucket that was just called enriched data, we could have one folder called pressure and one folder called temperature. And so we could use this kind of suffix here to scope what the Athena tables are looking at. And so at this point, CSV, and we have to specify the column so that it knows how to return data. So it's coming, put it over here. So with this, I believe we are on the pressure, so this is going to be altitude. So, cool. Next, create table. Pretty straightforward. Let's go ahead and create another table for temperature. So again, S3::. Let's go ahead and get that bucket name. Oh, wait, sorry, we need temperature bucket name. And again, we're just going to put that 2020 suffix on it because that's how Firehose delivery streams work. Back into the JSON, let's go ahead and just bulk add a bunch of columns. And at this point, we know with temperature, the outside temperature is the thing that we want from the message that we enriched with. So let's go ahead and do all of this. So go ahead and create this table. So we went ahead and walked through our manual steps. So at this point, like, we want to see it work, right? So back into Kinesis, and they make it pretty easy to kind of see this in action, if you will. So going into the analytics applications, wait, I went too far. Let's go backwards. Going into the analytics applications that currently exist, let's go ahead and start with pressure. Cool. So this thing's nice and started up. We've got, I think, important to show, we have configured our reference data. It's available within the Stream SQL as pressure reference table. Then we go into here. We'll take a quick look at the setup here. It's as simple as giving it the, I gave it the bucket name, and then also specified the columns in the CSV file. If you recall, we've got outside weather and site ID there, and then from the altitude standpoint, site ID and altitude. So that's where that comes from. I'll just go ahead and cancel out of this because we didn't make any changes. Get back into the SQL results, and here we can see that it's gone out and it's got data from the S3 bucket. I think this synchronizes on some sort of regular basis, but if you do seem like you're out of sync, you can go ahead and tell it to synchronize again. So if you go ahead and add a couple more rows to those files, if you want to view it here or make it update immediately, go ahead and synchronize the reference data table. So with all that being said, like, we want to see it work in real time. So this is the SQL, and honestly, let's go ahead and take a look at that in an editor, as that is much easier. And so we go ahead and create a stream called temperature analysis topic. And this is the output, so we give it the output schema. Actually, this might be easier in this window. So with that being the case, we give it the schema, like the columns to go output. We create a pump. This is why I say it's not like ANSI SQL compliant, because there is no pump in real SQL, or in T-SQL, if you will. So all this is going to do, we have to give it a name, but we're just going to go ahead and pump data into this pressure analytics topic that we named up here, that we are going to replace or create. And what are we going to pump into it? We are going to select a stream. And so at this point, it basically turns into what would be T-SQL. So source alias column name, output column name. So very, very SQL-like here. So we are just going ahead and selecting the columns we want. Important to know, we are getting altitude from an alias of T. And so where do those come from? What we're doing is we are joining the input data stream with, and it just uses pressure underscore 001. So so it just appends at 001 onto the simple name you give it. Then we go ahead and join the pressure reference table that I mentioned out there, and I gave you kind of a demonstration of showing the altitude, getting that from S3, etc. And here we're going to go ahead and alias that because I don't particularly like the practice of having to do this sort of thing on all of my select columns. So I've aliased that, and I've aliased the stream. So S for stream, T for table, joining on site ID, and additionally filtering on pressure. So at this point, we are now only going to output the pressure readings. So that's pretty cool. And say, hey, I don't have any data, what's going on? So at this point, let's go ahead and synthesize the production of sensor data. Sounds like a blast. So importantly, exported my stream name here from the stack that I just stood up. I have a producer, let's see, IAC, we're going to have to go up a directory, then into the producer. So create a complicated project, right? One py file, pretty good stuff. Really nothing better for just getting going, getting something up quickly than Python script. So using the Bodo 3 client, pretty excellent way to programmatically interact with AWS from Python. This is where I was, where I'm getting that stream name environment variable. Just go ahead and print it. And so I'm just going to go ahead and put out site ID, sensor type, the value, and the timestamp. Hard-coded timestamp could probably do a little bit better than that, but for the purposes of a demo, that I'm not even using that column. So, and also my string interpolation could be improved. Please don't roast me on the chat. With that being the case, go ahead and put a client record to stream name. We go ahead and take our message, which is just that JSON message, encode it into bytes, give it a partition key. Since it's a simple demo, we're going to go ahead and just give it a 1. So with that being the case, we can get the shard ID out of the response. If we had more shards for the stream, this would be a little bit more consequential. We're just taking the last shard ID from the last message we produced. We know that there's 1 shard, so we know that they're all the same anyways. So with that being the case, we go ahead and get the shard to read from, and all this is going to do is create an iterator to get some messages off of the stream. And so this is really more than anything just a sanity check that I put messages onto the stream. If I can read them off the stream, they're on the stream, would be my my argument. So with that being the case, go ahead, run this, and we have produced some records. I'm going to throw 100 of them out there. Wait for it. Wait for it. Cool. So now we're reading it. So I'm just going to go ahead and interrupt it. And so we can see here in our records, we've got like a sequence number. Actually, what we can do is, let's go find a better editor for this so we can take a look at it. So what does this message look like? Let's go ahead and jump back into Sublime. Let's go ahead and JavaScript JSON. So here we can see we've got the data attribute on this guy is the message that we've sent in. So I was trying to get this to do a pretty format, but I think I lost a curly bracket somewhere. So anywho, moral of the story is the message that we expect to see, at least the general shape of it, is on the topic. So that's pretty cool. So with all that being the case, I feel like, yeah, let's go ahead and produce again. I feel like it timed out over there. So produce some messages, and we will start to see things come in on the topic. So we're doing a sampling, so we're not going to see every message. But then also you'll probably notice that some of these sites don't have altitude. If you recall, that CSV only had sites 1 through 10. So given it's a left join in the SQL syntax up here, we will just go ahead and output a null column value for something that it does not is not capable to join on. And so pretty cool. So with all that being said, let's go ahead and jump over to the other analytics application. Much of the same. Get in here, make sure our reference data is set up correctly. So then you'll see outside ambient temperatures. So if we want to do any correlation between outside temperature and my manufacturing site running hot, we can do that. So pretty cool. So now we're out there looking for messages off the stream. We'll go ahead and just produce some more. And lo and behold, we are getting messages. Again, site 11 has nothing to join upon. So with that being the case, it gets the null value. But other than that, working pretty well. So at this point, if we go back to the diagram, gotta love a picture, we have now sent data in to the stream, archived it, enriched one kind of data from one bucket. Actually, these are the same bucket, just different directories in there. So we've enriched the pressure data from one CSV file, and we have enriched the temperature data from a separate CSV file, and then we are outputting that out to the Kinesis Firehose, and that is just going to go ahead and dump data into S3. So we now have an S3 bucket that has our enriched data, and so that's pretty sweet, because if you're scoring at home, once you get outside of the sensor producer, the Python script, the only code we've really written here is the coded infrastructure. You could do this all through the console, but I always recommend coded infrastructure. It's another conversation for another time. And then also the SQL code to go ahead and join the reference data with the stream data. So really, you could call this a low-code solution for sure. With that being the case, now that these are in buckets, we've set up the sensor Athena database to look at the buckets, and then we've created a pressure table and a temperature table. And just to kind of round out the architecture, Athena has a backing data store that it stores its results in. So we also have that bucket created as well. That's got less kind of, I don't know, end user value or business value if we were to be in the manufacturing business. So it's kind of auxiliary. It's a thing that Athena is using. It's out there, so I wanted to point it out. So with that being the case, back to the console. So all this is cool. So this is stop sampling and all that sort of stuff. So this is really just more for a UI, diagnostic purposes, etc. Really, if you were to do this in production, you'd want to make sure you've got your CloudWatch game tight and got everything logged, and you really want to do this, look at the activity in your data pipeline from CloudWatch. So this kind of airing out after a little while, not super consequential in a real production system. So with all that being said, let's go ahead and head back to the portal. So we've talked about these Firehose delivery streams, just plopping stuff out to these buckets, just kind of magically, automatically. And so, what does that actually look like? And so, Firehose will categorize your data by dates. And so, with that being the case, we have this blob of a file that's everything that's been put on the topic. So this is all of our raw data. So can't really look at it in the browser. Let's go ahead and take a look at it. Whoops. In a text editor. So as you'll see, very awesome. We've got all of the raw data. Since this is a JSON file, this will become important later. There are no commas on the end of these, and these are not contained in square brackets. So additional transformations could be desired on this data, but the long and short of it is we have the raw data, and it just kind of automatically gets splashed out into S3, which some could call a data lake, especially if you put something on top of it to query it. For example, Athena. So back to the buckets. We've got our reference data bucket. And then we've got, if I can spell, we've got enriched buckets too. So looks like I've got one that's been kind of orphaned out here. So looks like these two were created at roughly the same time. So I'm guessing this is just an old bucket that I forgot to delete. So all that being said, let's go ahead and take a look at our enriched data out here. So very similar to the raw data, since we're just relying on the mechanisms of Kinesis Firehose delivery streams. We've got the enriched data out here in a file for further usage. So get out here. Let's go ahead and also remove the sensor type, because we know based on how the query is written in the analytics application that if data were to get into this bucket, then it was going to have to be of sensor type pressure. So pretty good stuff. So now you've got kind of that metadata that we use to kind of direct data within our pipeline, but we no longer need the metadata once we enrich it, so we remove it. So we're starting to tailor the message to, really what is it that the end user is going to do with it. So we've transformed the data, we've added new columns to it, we removed columns that aren't necessary. I think along those lines, if you think about that, we've also got rid of each one of these messages coming out of Kinesis Streams has sequence numbers, timestamps, all sorts of metadata. We've lost that too. Our data scientists that would be using our Athena data lake probably have no interest in the internal workings of Kinesis data streams. So I would think, at least. Anyway, back to the data. So rounding this out, this is the pressure enriched data. Let's go ahead and just make sure everything worked as expected. So I'm typing backwards today. Temperature enriched data, vcool. looks familiar, right? Yep, so here we've enriched it with outside temperature, dropped the sensor type, dropped all the metadata from the Kinesis Data Stream communications, and then also zooming back out, you can see that Kinesis has just dumped all of these messages on the topics. They're not comma separated. Again, this becomes a little bit more relevant a little later in the conversation. So let's go ahead and jump into that aspect of it. So in terms of what have we seen from the architecture, that's the Python producer. We've seen the stream. We've looked into this Firehose delivery stream that's outputting raw data. We've looked at the analytics application that are splitting the data based on sensor type, enriching the data based on data in an S3 bucket, and then just going ahead and spitting that out into the enriched buckets. We took a brief tour of Athena. I think at this point, let's go ahead and dive into that, take a look at what it is offering us. Get the right browser. Athena. Coolio. If you recall, we went ahead and created our tables earlier as we were going through our series of manual steps. If you do not recall the manual steps, let's just go ahead and do a quick review of those. That was to close the spelling sidebar. Perfect. Go ahead and upload the reference data, start the analytical applications, the analytics applications, create the Athena tables, go ahead and put data on the topic, went ahead and viewed the raw and enriched data. So looks like we're right on schedule here. Very cool. So we have a table called pressure. Cool. So it's SQL, right? Cool. So there's a queuing period, then a running period, and went ahead and select star from pressure. I'm like, wow, there's only one record in there. What's going on? I'll get into that in just a sec. Just to prove the viability of the SQL syntax, we can do one of these. Okay. That language. Cool. So sometimes the queuing of the queries can take a sec. Let's see, what did I do there? We'll get this figured out. Cool. Site ID equals 3. So it looks like it went ahead, and since we've got some weird formatting from Kinesis Firehose, we've got some extra characters there. So anyhow. Anywho, if we want to play its game, we can go ahead and query this thing and get data back based on value. So the SQL is valid. The issue is, and also we can do the same thing from temperature as well. Cool, a little bit cleaner over here. So that kind of the dumping of data into the buckets without formatting them and then trying to use it in Kinesis is a bit of a thing. And so I go back to what I was saying earlier with the buckets. If you just go ahead and ad hoc just dump a bunch of data that was JSON through Firehose into a file. Looks like I might be having some bandwidth issues. Bear with me here. Anyway. Let's go ahead and jump back into the slide deck. So with that being the case, we're getting pretty close to the home stretch here. So we're going to jump into the coded infra. I wanted to kind of show you all around the PuluMe code and kind of talk through that. But anywho, just to, let's see, temp, pressure, yes, temp is So yeah, going back into the actual formatting of the data. I've already got it. I'm just going to go ahead and download it again. These all just being split out onto, this is effectively a file that has one line in it. And it's just appending the messages onto the end. And so in part 2 of the series, first thing we'll open up with is how to fix this. I will give you a hint. Part of it involves some transformation and a format change into a more data science natural format. And so with that being the case, I think the AWS Meetup group would like to offer out a coding challenge. If you post the solution to format the data coming out of a Firehose delivery stream in a way that works with Athena, to where that each one of these are queryable as an individual record, post the solution into the event page. We'll buy you a beer. Ideally, we would do that in person, since we normally present over near Galvanize. It would be a different beer company. Given the quarantine, we're going to have to Venmo you, but it'll still be fun. Pick up free beer. Anywho, so we'll get into correcting kind of the formatting of data coming out of Firehose so that it plays well with Athena in part 2 of the series. I just didn't want to get too deep into that, and there's a ton of content here. So with that being the case, let's go ahead and jump into the code itself. And so to talk about that, let's go ahead and just take a look at the stack that we are creating. And so the first thing that we do is, that should be a little easier to view, is create a bunch of buckets. So what does that look like? Pretty simple. So this is the C# SDK for PuluMe, and if you've used Terraform before, a lot of these parameters look really familiar. And so it's built on the Terraform bridge, and so you get a lot of the same capabilities in terms of the providers, the ones that have been implemented. Terraform has many more providers than PuluMe. But the ones that are implemented in PuluMe, done very nicely. I think the V2 of PuluMe with C# support, after coding out an entire data pipeline stack, I would say I thought it was a good experience. I think they've done a great job, so definitely good work on their V2. Good job, PuluMe. So with that being the case, that is the creation of S3 buckets. And so we go ahead and set up our sensor topic name. You'll notice here, this does not look like what came out the other side. And so with that being the case, actually let's just go back into, it's going to be easier to look at the stream name inside of the console, as I ran the Python producer a few times. So yeah, our stream name has this little mini hash, if you will, appended to the end of it. That's a thing that is done in order to ensure that if you redeploy, you're getting unique names. And so if you've been wondering where these crazy little hashes on the end of all of my resource names have been coming from, it's a built-in behavior of the coded infrastructure framework. So pretty cool. So with that being the case, what does it take to create a stream? Honestly, I should have closed this a while ago. And let's go ahead and expand this out. So the stream creation uses the AWS Kinesis library. Pretty cool stuff. And it's just create a new stream. Give it the topic name. Stream name probably be a little bit better variable name here. So never too late to change variable name to make the code more readable. And go ahead and give it some stream args. So I talked a little bit about shards earlier, levels of parallelism within your Kinesis processing. We have a tiny amount of data, and I don't want to spend a bunch of money, so I went with 1. Retention period, that is in hours. Then also highly recommend any coded infrastructure projects. Really anything that you put out in a cloud platform, go ahead and put some tags on it so you know who owns it, who needs to pay for it. Really key portion of enterprise cloud computing strategies is a tagging strategy in order to perform activities such as bill back and show back, in order to understand who is spending the money within your enterprise. Pretty easy when you have a small group like my multi-cloud consulting group. Certainly not small by consulting group standards, but it's certainly not enterprise size. It's not 5,000 of us, for example. One day we're growing like a weed, but not quite yet. So here I'm just going to go ahead and apply some tags so that like if I need to go and look up all of the things I made, for example, for some reason I lost my PuluMe state, which would be kind of hard to do, but you could type in some commands that make that happen. Anywho, so diving into using IntelliJ keyboard shortcuts in Visual Studio Code, not working well for me. Anywho, so I'm just putting my app name on here so I can go and search in the tag browser within the resource groups section of the console to go and find anything owned by Tink. That is my username, 10K. Excuse me. Anywho, so diving back into the actual data science stack, we have a Kinesis Stream now. Very exciting. So staying in the theme of Kinesis Streams, let's go ahead and create our delivery streams. And so one of the things I've really not talked about very much is security. And so if you think about the resources that can have data in them, you got S3 buckets, you've got streams, and anything that wants to go read or write to a bucket or a stream has to be explicitly granted the permission to do so. The whole zero trust security model that every cloud platform is adherent to. So with that being the case, I go ahead and create this role. It's going to use it across 3 different Firehose delivery streams. I think in a production environment, you would probably want to create an individual role per each one. So maybe you just wanted to turn off one Firehose, some process you worry about it becoming malicious for whatever reason. Certainly a number of reasons that you might think that, but you think you've been hacked, so you want to go turn that off. If you have like a role per stream, that makes it a little easier to just turn off access at the per stream level. Given I'm just doing a little demo, I just created one role to rule them all. So so what we're saying here is in the assume role policy, the service is Firehose, and what we want to do is we want to give it, I've given it very loose access. Again, in production, you would definitely want to specify individual S3 bucket Amazon resource names. That's what ARN stands for. Individual streams as well. And then also, when we get into Elasticsearch, that ES prefix, service prefix, that's Elasticsearch. So at this point, our Firehose role has the ability to interact with S3 and Kinesis and Elasticsearch in an unbound way. Again, in production, you will want to probably be explicit about the actions and the individual resources. Just a word to the wise. Also, if you're working with enterprise customers, that's a compliance issue that you'll want to solve for them. Certainly a value add that you can give to your customers without saying is giving them a good security posture. So please do that, especially for your customers. With that being the case, we have created the delivery streams. And what do the delivery streams take? In terms of a generic creation, we take a name for the stream. We have the stream. This is the input stream. And so again, never too late to rename your variables to make the code more readable. Let's do that. Input stream name. Let's go ahead and say this is the output bucket. Amazon resource name checks out, and then the role name. And so that's our role that is just going over the Firehose role. So with that being the case, go ahead and configure a source configuration. That's our input stream. You don't give the Firehose delivery stream the role. You give the source configuration the role. And so why is it like that? And so the short answer is the reason it's like that is so that you can use one role to connect to Kinesis sources, and then with your S3 configuration, you can use a different role. Again, my security is not super granular, but this is a thing that you definitely want to do in production environments. So I told you earlier that you can output to a whole lot of different things. One of the cool things I like about PuluMe is you can go and view the source, and this basically gives you documentation. Code is documentation, big fan. So easy as standing up an Elasticsearch configuration. this is pretty neat. The extended S3 configuration will send your records through a Lambda and then into S3. So if you need to get into like really heavy data transformation, enrichment, where you're calling other APIs, like just really in a non-trivial enrichment, non-trivial ETL task, if you will, you can use this extended S3 configuration to throw Lambda at the problem. And if you can't solve it with a Lambda, then, well, I don't know. I can solve most things with a Lambda. So I think that's a pretty good tool for the old tool belt. Also, the source and the source configuration, we looked over that. And then also a Redshift configuration for output to Redshift and S3 configuration for outshift to S3. We just went ahead and wired up the S3 output. Did this in a method with some generic, kind of some genericism so that I could do it 3 times in a row without repeating too awfully much code. Cool. So at this point, let's get into the stream, the Kinesis Analytics applications. Again, these are by far the most complicated portion of today's demo. I didn't have a great way of genericizing them without just creating an arguments object. This got super wide and I didn't really want to pin that into my create analytics applications where I was passing in like 10 columns. It gets ridiculous. So went ahead and made this analytics app S3 enrich args. And so let's just go ahead and take a quick look at what we got going on here. The reference bucket. The code, that's the SQL command, the stream to get data from, the output, Firehose delivery stream to send the data to, the role to use to connect to various resources. We put a name prefix in here, so that's where we see like pressure or temperature. So that's a required field in these analytics applications. The columns that are coming in from the stream, the output format, and also we have a reference file. That's the reference file key. That's the S3 key of the file. That's the file name in our case. And then the columns of the data coming in from the reference file. So all that being the case, what's it look like? Our input stream, site ID, sensor type, sensor reading value, reading timestamp. From the weather file with ambient temperature, site ID, we join on that. Outside temperature, we enrich with that. Same thing with altitude. Join on site ID, enrich with altitude. So with all that being the case, we output in JSON, and we go from there. So we'll just dive into that constructor real quick here. So new analytics application. And again, this is by far the chunkiest portion of the code. The code is the SQL command. So I went ahead to make this a little more readable. I put these out in the static class with the read-only temperature and pressure queries. So that's where those live, if you were wondering. Back into here. So go ahead and set up some CloudWatch. If you want to do this in production, you want to start monitoring the activity from the logs and not the analytics application UI, as I mentioned earlier. And so with that being the case, set up some logs. Thank yourself later. And then we talk about the input args. And so with that, we're going to go ahead and pull in from the Kinesis stream. We give it a name prefix. We go ahead and give it a schema. And so with that being the case, we're just saying that everything is coming off of the root of the object. If you had a more complicated JSON payload, if you're familiar with JQ, where you can kind of go in and reach down into JSON messages and pull back based off of identifiers, you can get pretty crazy here, and you can go ahead and start with a non-root element of a JSON object. Probably an advanced conversation for this, but again, hit me up on LinkedIn or the meetup, and I'm more than happy to talk about that if you got a use case where you think that might be relevant. And so then the record columns for the input, I just go ahead and take those 4 columns that are on the message, the ones that I want at least, and I say go ahead, and I just go ahead and select a new record column out. So I will say the C# PuluMe SDK, a little bit more verbose than say the JavaScript or Python example. With the JavaScript or Python SDKs, these would look a little more like that, but to each their own. If you're writing a project in C#, you don't want to switch to another language to write your infrastructure. So extremely powerful. Like I said, they did a great job with it. So I just go ahead and set up all of the input columns. Then with the output, I go ahead and specify the output topic name. And so there's that name prefix again, for example, pressure or temperature. And so you'll see this reference in the SQL. With that being the case, we're going to go ahead and set up our output to send all of this data to Firehose resource name and a role that can write to it. So pretty similar, this pattern all over the place. Anytime you have something that connects to a resource that you want to read or write to, you got to go ahead and set up your security, create your roles, etc. And I can get into that role creation. It's a little messy. I could refactor it. It could be better. But we should dive into it just to make sure that you all are aware of it, that you're seeing it, and we have basically looked at all of the code so you understand what's going on. And then also the output format, we have provided JSON there. And so the final piece of this, and I think the really cool part, is this reference source, where you go ahead and you create your reference table that you can access from within your SQL. We go ahead and set up the S3 source. We give it the bucket, the file name, and the role to read to it. Again, ongoing pattern. If you're reading from something, writing something, you got to have a role that has the authorization to do so. So pretty straightforward. And then here we're going to go ahead and give it some information. So for the schema, this is a mouthful. Schema record format mapping parameter, which basically is a kind of a fancy way of saying the CSV args that this is the file format that we want. So you can specify CSV here, or you can specify, told you here, Visual Studio Code getting in the way here. So you can specify CSV or JSON. You can specify one or the other. You obviously can't specify both. A thing that I discovered in this was, let's see here, I can do these mapping parameters, message format type. Although you can come in here and set that. Let's see, where are you? This one, message format type, record format type, yeah. So it's like this one. So, I mean, you could easily come out here and say, my file is CSV, right? Yeah, this will blow up. Apparently, this record format type, while it is something you can read to or can write to, really should be a read-only property, as that gets set based on the mapping parameters that you throw in there. So this would currently blow up, even though these two agree quite nicely. Don't set record format type on your output schema. Lost a few minutes to that discovery, to say the least. Anywho, the final piece of this is we're going to take those reference file columns and go ahead and define a schema for those columns. And so going back over here, just as a refresher, that's site ID and outside temperature, site ID and out2. So that is where we're at there. I realize that's a whole lot, and we're kind of zooming through a ton of code, but I did want to kind of just show you the arguments, the inputs, etc., as to help you better understand how the components really work. All right, so we're in the home stretch here. We have created the analytics applications, all the fire hoses, all the streams, all the buckets. So now flow data into the input stream. If it's pressure or temperature, in terms of sensor type, it just flows out, gets enriched, gets thrown into S3 buckets. Pretty sweet, pretty sweet. So the final piece of this was, wanted to go ahead and create the Athena database. We had to create the tables manually. I did not see, let's see here, go to create database, go into database. I just didn't see, let's see, I didn't see table. And so maybe one of those things, I was going to dig into the namespace, but actually I probably don't want to do that on the stream. It's incredibly boring. Had to create the table manually is the long and short of that very long story. Anyway, so I created the database. I added a comment here, need to manually create the tables. And then finally, what are we doing? Probably need to make that a little bit more clear that that has nothing to do with Athena. And here we're just going to go ahead and set our output variables. If you recall, let's see here. Make this a little larger. Sorry, I didn't do that earlier. More clear. So we're in the IOC, so PuluMe stack output is a way that you can go and get all of your output variables, or if you have one in particular that you care about, you can just name it and it just gives you the value. That was what we did earlier when we put the stream name from the stack output onto the environment variable stream_name, all caps. So this is a pretty useful, this is a very useful feature. And you know, it exists in Terraform, CloudFormation, PuluMe, etc. So this is very common, specifying your outputs, because once you create something, you're probably going to need some information about the resource to use it. An example would be, what if I created an RDS database but didn't know the password? That's commonly an output from a stack. Then, you know, you've also got other things such as bucket names, stream names, etc. If you create an EKS cluster, you can use the stack output to actually output your kube config, which is incredibly awesome. So you can automate the creation of a new EKS cluster and the exporting of the kube config, so you can run, you know, a single command, basically run a shell script to make your infrastructure and set up your development environment where you can do kube control and you're just into the Kubernetes cluster. So there's pretty valuable, I think, valuable use cases of this export stack business. If you want to use the export stack business, you have to set the outputs. So variable assignments, nothing crazy there. Another thing, and you could probably put these at the top of this file. I've got them at the bottom. Typically I put public variables at the top of things. Just happened to work out this way. So this is perfectly valid syntax. So we can go ahead and take off these decorators, the output decorators. All this compiles and it's great. But if you don't have the decorators, then none of these actually get output. So, very common when doing this is, hey, I want to add another output variable. I'm just going to go grab this line, create it down here. We'll call this new output var. Good to go. The actual class itself will yell at you because you're not setting it. So, you know, go and set it. Blah. Cool. So if that being the case, you would not see let me the code correctly. Oh, so yeah, so these are things that have this output type comes off of these, and so. Well, it's kind of like it's deferring. It's saying, give me a container for type string that I know you don't have right now, but you're going to have it later. So anyhow, let's say I wanted the new output variable to be the bucket name that Athena is using. Pretty standard stuff. If we were to do a PuluMe up and update all of the stack, which the real updates here are going to come from change a couple variable names, that shouldn't really change the stack. Yeah, there shouldn't be any major changes here. It would just output the new variable name, or so you would think. But we didn't decorate the variable correctly, so I'm mentioning this because I've done this several times. Like, hey, I'm going to go add a new output variable. Forget to throw that on there. Say, hey, where's my variable? Have to go do a stack up again. So just a little time-saving advice there. So I think with that being the case, we have pretty well exhausted everything, with the exception of. No, I think we've pretty much gone through all of it, all the stuff I've used for this meetup. I've got some stuff coming with IoT. You can script out a bunch of really cool IoT stuff. We touched on the queries, so I think we're in pretty decent shape here. So, cool. I think at that point I have pretty much gone through everything I have. So in terms of a conclusion, we got into, why is it that we want to create a data pipeline? Data pipelines get us closer to event-driven architectures. Why do we like event-driven architectures? Because batch-based architectures don't scale and become hard to manage. So we've got into that a little bit. I got to try out some new diagrams. I hope they worked. Hope they conveyed the information. Overview of the demo architecture, the POC architecture, I believe it was called earlier. I went ahead and deployed the infrastructure via the coded infrastructure. Took an overview of the individual AWS components used: Kinesis Streams, Firehose delivery streams, analytics applications, Athena, S3, quite a few different things to play with. Let's see here. I think I should have cleaned this slide up. Whoops. Anywho. And get that. And Galvanize is always great to us. Unfortunately, we've had to do this on live streams only. So yeah, like I said, thank you for tuning in, and please hit me up on either LinkedIn or the Meetup event page if you want to talk further. I've got a Q&A session. I know we may have had some stuff coming in off of the live stream, so I'll get into that. Before we do, just a quick plug in case you need to take off, you're out of time. The last Wednesday of next month, I'm going to do part 2 of this. Part 2 will include the full Athena implementation, get into Redshift, get into Elasticsearch. We'll start talking about integrating Redshift with S3. We can also talk about other sweet data things. If there's something in particular in terms of AWS data services that you would like to maybe talk about, get an example for, feel free to drop us a line in the meetup and let us know what it is you're interested in, where this is a month out. If we get some good ideas from the meetup members as to where you would like part 2 of this to go, something that maybe would help you solve a problem at work for one of your customers, your IT department, etc., let us know. We really want this to, really kind of serve the needs of the meetup community. So don't be shy. If you've got things you want to see, please let us know. Also, second Wednesday of May, Austin is going to be doing the second part of his AppSync meetup series. That's pretty awesome stuff. Big fan of what AWS is doing there. Let's see here. I thought there was another meetup scheduled, but not quite. And then last Wednesday of June, I'm going to get into some IoT core capabilities. Hopefully actually get into writing some software on some Raspberry Pis maybe to interact with IoT core, and also getting into how to control devices that communicate with IoT core without communicating directly to the device. Instead of, you can use IoT core as a proxy to change the behavior and state of devices. Really pretty powerful stuff. But with that being said, I guess I'm going to turn it over to the QA portion of the meetup. So, to begin anything on the live stream, any kind of questions? Do you want to Slack them to me, or? No. Nothing from the live stream? Well, I guess it's because it's a pretty thorough explanation of the subject matter. Or everyone went to sleep. Could be either. We'll just call it the former and call it a day. Anywho, I think we're going to go ahead and get out of here. Parting words, WWT, company I work for, a very good company, bunch of very smart people. We do a ton of data pipeline projects, all major platforms. And so if you're potentially interested in talking through the ins and outs, technical details, pulling off one of those projects, or if you would like to maybe engage worldwide to implement your data pipeline project, please hit me up. More than happy to kind of geek out and talk shop. I'm super passionate about all things data streaming and event-driven architecture, so please reach out. More than happy to talk. And with all that being said, thank you for tuning in, and catch us on the next meetup. I think we'll be live streaming it as well, but it will be here in just a couple weeks, so please please tune in and check out Austin's AppSync Part 2 meetup. Hope everyone has a good night.